Hey guys, tonight we are continuing our trigonometry review slash, maybe some new stuff for you. Today we are going to be finding missing side lengths and angles using the trigonometry ratios we learned yesterday. So write your essential question at the top of your page. Make sure you leave some space for your Q column and your summary, and let's begin. So the first thing that they are going to ask you to do is we need to solve, quote unquote, a right triangle. And all that means is that you're going to find all the missing sides and angles. So go ahead and pause, make sure you draw this little diagram for yourself. And since I have a lovely diagram, if they didn't give you one of these, you might want to draw one. And then I'm going to label what I know in my diagram. So I know that B equals 5. And I know that the measure of angle B is 38 degrees. Okay, so what that means is I've got to find all the things that we don't already know. So for instance, I have to know what the side length A is. I have to know what the side length C is. I need to know the measure of angle A. And I need to know the measure of angle C. Well, sometimes it's easy because, look, it's already marked. So angle C is 90 degrees. Got one thing that I don't have to do now. And then if I want to find this last angle, all I have to do is know that all the angles of a triangle add up to be 180 degrees. So I could take 180 minus 90 minus 38 and find out that the measure of angle A is 52 degrees. Okay. So now we've got to worry about side A and side C. Now what I'm going to tell you right now is that you should always try to use the things that were given to you. So the things that I wrote in black are the things that I kind of want to use, because if I make a silly mistake and I get the wrong value for A and I use that to find C, now I've missed 2 questions instead of just possibly 1. So try to use what they've given you. Sometimes that's not always possible, but if you can, let's do it. So the first thing is I know this angle down here, 38 degrees, and I'm going to go ahead and say I want to find A. So in order to find A, I have a side that is adjacent to my angle and I have a side that is opposite my angle. So I always kind of at the top of my pages when I'm doing any sort of trig stuff, I write SOHCAHTOA. I'm thinking about trig functions that have an adjacent side and an opposite side. Hey, that's TOA, that's tan. So in order for me to find A, I'm going to take the tangent of the angle I know, 38, take the opposite over the adjacent, so my opposite side is going to be 5, and then my adjacent side is A, I don't know it. And now I'm going to have to figure out what this answer is. So when you are solving these things, you can solve this as a proportion, and you can flip-flop these guys. So then we have, if I cross multiply and solve here, I would have A times the tangent of 38 equals 5. So if I wanted to solve this for just A, I divide both sides by the tangent of 38. Okay, so now I'm going to put that in my calculator. Please, please, please make sure your calculator is in degrees. Well, I'm going to try to pull up my calculator. Here we go. So again, make sure your calculator is in degrees by pressing mode, go over to degree. And now I'm just going to do 5 divided by the tangent of 38. Okay, and so I find that my side length A is about 6.3997. Remember, we're going to round to 3 decimals, and so looking at that, that's going to round up to be 6.400. So I have one side down. Okay, and as nice as knowing that side is, again, I'm going to try not to use it in order to find my last side, because just in case I made any sort of mistake, I want to make sure that I have the right answer for at least one of the sides. Okay, so I'm going to do C now. That's the hypotenuse. So I have 2 different functions that use the hypotenuse, and again, I want to try to use something that's given, so I'm going to use the side that's opposite. Opposite over hypotenuse is sine. So in order to find side C, I'm going to do the sine of 38 equals the opposite, 5, over the hypotenuse, which is C. I don't know that. We're going to use the same solving process. So in your calculator, you're going to end up typing in that 5 over sine of 38 the sine of 38, and I would get that that side is about 8.121. Okay, and make sure all of your side lengths make sense. You know, your hypotenuse is the longest side, your angles don't add up to be more than 180 degrees, but we have now solved this triangle and we found all the missing side lengths and angle measures. Okay, I'm going to do one more example of this. This guy only gave me 2 side lengths. So again, I'm going to label the diagram with what I know. I know that A is 4 and C is 15, and I don't know any of the angles. So again, off to the side, I'm going to write down what do I need to find. I need to find side B. I need to find the measure of angle A. I need to find the measure of angle B. And I need to find the measure of angle C, which I already know is 90. So got half of that. Got 3 things left to find. So you're looking at this and you're like, well, hey, this is a right triangle, and I have 2 of the sides. I have a leg and a hypotenuse. Can I use Pythagorean theorem? Of course. So remember, a squared plus b squared equals c squared. Plug in what you know. You know that 4 squared plus I don't know what b is equals 15 squared. Okay? If you do that math, you'll get b squared equals to 209. And because this one did say we could round in the instructions, or maybe I didn't even write the instructions, I am going to go ahead and just round this to the nearest third decimal place, and I get that b is about 14.456. So I know that last side measure. But again, I'm going to try not to use it if possible when I am looking for the angles that I'm missing. Okay, now this is kind of a element of your choice, whatever you want to do, whichever angle you want to find. Again, I want to try to use these 2 sides that I know. So I'm going to go ahead and find angle A. And since I know the side that's opposite and I know the hypotenuse, I'm going to use sine. So sine of I don't know equals opposite over hypotenuse. And then I can go ahead and use those calculator skills that we learned yesterday in class. I know you don't have a calculator, it's okay. And if you want to call that A, that probably makes more sense. In fact, I'm going to change it to an A. So we're going to go ahead and say that A is the arc sine, or the inverse sine of 4 over 15. And you would write that into your calculator, and you find out that A is about 15.466 degrees. Okay. Now you are welcome to do that for angle B, to go ahead and find the cosine of that angle, or to use this last side length. But because I know that the angles in a triangle give me 180 degrees, I can just take those things that I know, and I can take 180 first. 180 minus 90 minus the 15.46, or I do believe this asks you to round to the nearest degree. So if we want to forget that 46, we can, and we find out that measure of angle B is about 75 degrees. So again, you found out all the missing sides and all the missing angles using that trig. So we're doing those applications. The last thing that I want to talk about, and I know this is going to probably make my video run more than 15 minutes, I'm really sorry, but we have the angle of elevation and the angle of depression. So when I'm talking about angle of elevation, angle of depression, this is usually in those word problems. And so what I want you to imagine, there's 2 people, you and your friend are hanging out. Somebody's on the top of a hill, somebody's on the bottom of the hill. And you want to say, you know, what angle are you looking at? So whenever you're talking about the angle of elevation and depression, it's always in relation to a horizontal line called like a horizon. And a lot of times that's going to be like your eye level, or they'll tell you, you know, it's with the ground. So that's going to be my eye level for that top. So if I'm trying to find the angle of depression for that guy looking at the other guy, this right here, this angle inside, this is your angle of depression. So you have to be really careful when you're drawing your triangles that you recognize that the angle of depression has to be with that horizon line, with that horizontal line. Similarly, if I was to think about the guy looking up and you wanted to find the angle of elevation, you would have to draw his eye level line, and then the angle going up is the angle of elevation. So we're going to use these two keywords or two key phrases in order to solve word problems using the trigonometry stuff. So again, this is kind of a nice diagram. Remember, you have to have your angle going from some horizontal line in order for that to be a correct angle of depression or elevation. So let's look at an example problem. A bird sits on top of a lamppost. The angle of depression from the bird to the feet of an observer standing 25 meters away is 35 degrees. How tall is the lamppost? So I'm going to tell you here, you need to draw a diagram. I don't care if you're an artist, draw yourself. I'm not an artist. I'm going to already give myself that disclaimer. So I have some bird. Yep, that's my bird. And he's hanging out at the top of a lamppost. I have really creative lampposts. Okay? And we know that there's some dude standing over here, and he is 25 meters away. Okay, so from here to here, it's 25 meters. I then know, I want to know, they have the angle of depression from the bird down to the feet of the observer. So we know that we have some sort of angle of depression going from here to here. Now remember, that angle is made with a horizontal line, so like with the bird's eye line. So when I look right here, this is my angle of depression. So I have that's 35 degrees. Okay, and I'm looking for the height of the lamppost. I almost said flagpole. You know, they're always like a flagpole or something like that. So when I'm looking at this, there's a couple of ways you can solve it. The first thing you could do is if you just wanted to solely deal with this triangle. Let me show you which triangle I'm talking about. This triangle right here on the inside, you could say, well, how would I find this angle in here? You could go ahead and take 90 minus 35 and get that as the angle that the bird is like looking down. Okay? The other thing you can do, and we kind of talked about this on Tuesday, is when you have two parallel lines, which we know this horizon line that the bird is looking at and the ground are parallel, I then know that this angle and this angle are the same. So this angle right here is going to be 35 degrees. Again, you can use whichever one you want if you'd rather do the minus thing, but just make sure you're being careful, especially with angle of depressions. Okay, I'm going to go ahead and use the one using the parallel lines theorem thing, and I'm going to say, well, I'm trying to find x. I have this side that's opposite my angle. I have the side that's adjacent. So I'm going to use tangent. So tangent of 35 equals opposite, I don't know, over adjacent is 25. I'm going to go ahead in my calculator, I type in 25 times the tangent of 35, and I'd find out that that is approximately 17.505 meters tall. And again, make sure it makes sense when you do it as far as what your final answer is. Okay, I want to do one more kind of tricky question. Has a couple of different things built into it. This one says buildings A and B are across the street from each other, 35 meters apart. From a point on the roof of building A, the angle of elevation of the top of building B is 24 degrees and the angle of depression of the base of building B is 34 degrees. How tall is each building? So, draw yourself a picture. Here's my street. Here's my building A. I'm going to arbitrarily say that building A is the smaller building. It doesn't matter which one you choose. And then I'm going to have building B. Wow. Wow, this is a feat of architecture here. Okay, and then I know that they are 35 meters apart. Then I know that if I take a point on the roof of building A, the angle of elevation to the top of building B, well, you know, it's up here. And remember, this is going to have some sort of horizontal line. That angle of elevation is 24 degrees. Okay, and then it also says the point to the bottom, to the base of this guy, the angle of depression is going to be 34 degrees. So this is the picture I've got. Now I want to know how tall is each building. So I need to know this length, I need to know A, and I want to know B. And again, there are a couple of ways to solve this. You can break this down into however many triangles you need to. Just realize we can't actually use the giant triangle because we don't know that it's a 90-degree angle, so we can't use any of our right triangle trig. So I am going to start with the one that has the angle of depression on it. So from the top to the bottom. So I'm going to kind of break my picture down. Well, you know, I tried. So I have a right triangle. Remember, this would make a right angle because that is the horizon line. This was 34 degrees. And then I know that if this distance is 35, surely we don't have any slanty buildings. I mean, mine is kind of slanty, but it's okay. This is also 35 degrees, or 35 meters, sorry. Got to know what I'm dealing with here. And then this, if I'm looking right here, if you notice, this length is going to also be equivalent to this length and get me A, okay? And again, you could have drawn that opposite triangle down here, found out what this measure was, and done the same thing. So now, I know that this is, sorry, I didn't even tell you, I have the side opposite my angle, I have the side adjacent to my angle, so I'm going to use tangent. Tangent of 34 degrees equals A over 35. Solve that using my calculator, and I type in 35 times tangent of 34, and I'd find out that A is approximately 23.607 meters tall. Okay, so I found one of my answers. I found how big A is, and I did that using my angle of depression. Now I need to find out how tall B is. Okay, now I can't find the whole measure of B, because remember, this guy isn't a right triangle. The whole triangle isn't a right triangle. So I'm going to use the little chunk at the top using the angle of elevation. So if I look at that, if I just pull that part of the picture out, again, this makes a right angle. I have 24 degrees here. I don't know this length, and that's not actually B. I think I'm gonna call that X, because when I look right here, the whole length is B. So if I want to figure out what that little chunk is, I'm going to give it a new name. And then again, they're still 35 meters apart. So now I have a very similar question. I have the side opposite the angle. I have the side adjacent to the angle. So I have tan of 24 equals X over 35. Do my thing, 35 times the tan of 24, and I'll find out that that little chunk is about 15.583 meters tall. Okay, you're like, I'm done. But remember, building B is the taller building, and you just found a number that's smaller than building A. So your last step, and I know this has been a long problem because of that fact, because it's a pretty involved one. We're going to have to take the measure I got for A plus the measure I got for X, and that's going to give you B. So I'm going to have 23.607 plus 15.583. And I'm going to find out that that building B is approximately 39.19 meters tall. Okay, so that's building A, or B. Okay, I know, that was a lot. We're going to work on word problems tomorrow a little bit more. Just keep going in there. Make sure you draw a picture is the biggest thing I can tell you. So remember, before you're done with your notes, you get a 7 out of 10 for completing your notes. You need to have a completed summary and at least one level 2 or level 3 question in your Q column before class if you want that full credit. Okay, I hope you have a great night.